Okay, so my friend, last time we
Mm,
completed the default routing configuration, but now we are moving to some advanced default routing configuration. In that, we will be configuring some kind of multiple default route path. Okay, so if you have multiple default route path, okay, how it will be connecting, how it will be forwarded, okay, how it will be
mm,
communicating. So we will be checking that. Okay, see, my point is that when we say default routing, see, understand first default routing. What is default routing? Default routing is if your router is here, which is connected to two different ISP1 and ISP2, right?
mm,
Now, whenever your router, whenever your router, okay, whenever your router wants to communicate to ISP, Internet Service Provider, okay,
mm,
so your router will forward the request of your internal users to ISP1 or ISP2. So always keep in mind, default route is always used when you have single link connected to ISP. Means, suppose you are inside your house. This is your house.
mm,
Inside your house, if you have some your friends, your mother, your brother, your family members like that, and you have single door, exit door. So
mm,
if any person is coming to you, please, I want to go out, you'll say, oh my friend, go from this, go from this, go from this, right? But
mm,
if you, so this, when you have single exit point, so default route is configured in that case. But when you have
mhm,
multiple exit point, right,
mhm,
at that time default route is not recommended.
mhm.
Okay, but if you have some condition like that, but in that also you can configure, no problem in that. So we are working on that. Okay, how to configure default route with multiple exit point. Okay,
Okay.
so for that we will be taking our lab. Okay, so we can say here default routing load balance. So here we are taking some routers. So router 1, and then you have router 2 and router 3. So this router 2 and router 3 is acting as a ISP. So what we are doing, we are changing the icon of this or symbol of this router as ISP. So
Mm,
select it, right click and change symbol. Okay, now we can change the name, right click and change host name. So R2 is acting as a ISP1 and this guy is working as a ISP2, R3. ISP1 and ISP2. This is your internal organization router, and inside your router you have router, and then you have switch. Okay, layer 2 switch, layer 2 switch. Okay, and inside your organization you have some computers like this PC1. See, if you want to make multiple same device, so you can duplicate also. So to have, see, PC2, PC3, and PC4, like that. Okay, and now part of connectivity. So for connectivity, what we can say, we can take these cables. Okay, this cable we can take. So click on this cable and just click on the devices. Okay, you will select the port number and connect it. See, why? See here, on PC you have single interface, so select that interface. On switch you have multiple interface, so we are selecting red one, not green one. Red means not used, green means used. On router you have multiple interface, ethernet and serial. So depending on your scenario we should use. So we can use, see, if we are connecting from switch to router, so always ethernet, fast ethernet, giga. Okay, but if we are connecting from router to router, so we can take ethernet or serial, no problem, but the cable must be same. It's not that this side ethernet and that side serial, no, it will be wrong. Okay, then here we have to provide uh, interface names. Okay, the what name you are, the port labels you can say. What is the port number is there. Okay, okay, so here you have to click this ABC. So when you will click on this ABC icon, you will see that okay, these are the port numbers. Okay, and here I already told you that in these situations, when you have these computers with port number, so here port numbers for computers are not important. Port number for routers are important. Okay, we can remove it so we can see the clear picture of your devices. Okay, one more thing again in this lesson I'm telling you that maybe suppose by mistake I remove, like by mistake the port name has been shuffled, maybe. Okay, by mistake I have placed in wrong area or with the wrong port number. So if you put your mouse here, it will say that router 1 port is serial 2 and ISP2 port is serial 2 by 1. Okay, so port number is there, so you can say okay, now you can correct it. Okay, 2 by 1, 2 by 1. Here also see router port serial 2 by 0 to ISP port serial 2 by 0. So I, okay, port serial 2 by 0 to serial 2 by 0. Okay, now what you have to do here, we have to assign some loopback addresses for the organization. So loopback 1. Okay, loopback 1 is also one type of network. So I'll say 1.1.1.1 slash 32, and here we can say minus 90. Duplicate. Here also same network, because see, now you will say that okay, why we are having same network, because when you are connected to ISP, multiple ISP, so from this side also you can reach Google, and from this side also you can reach Google. That's why same IP address we are using. That's why we can check whether it's doing load balancing or not. Okay, now here, okay, so here we are messing with the network IP addresses. Okay, so here we are using 12.1.1.0/30, and here we are using 13.1.1.0/30, and here this side we are using 192.168.10.0/24. Okay, so remember, in any lab I used to write that, okay, what is the process. So first you design the lab, designing is completed. After that, connect the devices with correct cable. Then you say number 3, configure IP addresses on the devices, and then number 4, routing will come. Okay, so first start the devices. All devices are started. Now you take a console of the devices. So here we have taken the console of the devices, PC, ISP1, ISP2, PC. So now first we will come to router 1. Router 1 has 3 interface, so I'll come here, okay, so conf t, then interface serial 2 by 0, same name. IP address, we are using 12.1.1.1, and subnet mask is /30, that's why it is 252, and no shutdown. No shutdown means enable the interface, shut means disable the interface. Okay, and exit. Then second interface serial 2 by 1, so you have to type here interface serial 2/1, IP address 13.1.1.1/30, that's why no shut. Okay, so two interfaces configured, now remaining with one interface, which is E0 by 0. So you type here interface E0 by 0, IP address 192.168.10.10, 255.255, and then enter. So configuration is completed. You can exit. You can exit from here also, and then you can write to save. Okay, save the configuration. Now PC will come. So what IP address here we are using? We are using here as 192.168.10.10. So this IP address what you are using on this Ethernet interface. Okay, so this IP address will be used as a gateway of these devices. So you can see here, you can write as a gateway. This is the gateway of your network. So all users or all host or all system of your network will be using this IP as a gateway. So you come here to PC1, you say okay, IP 192.168.10.1/24, but gateway is 10.10, and then you save here. This is the save command on PC, because this is a virtual PC. Okay, now here 10.2/24 subnet, save. Now you say okay, another process you can write like this also, IP 192.168.10.3 space 255.255.255.0, and then gateway. You can use this command also, or you can use slash also.
Yes.
So you have all option.
Mm.
Okay, and then you can save.
Mm.
So PC configuration is completed, PC IP configuration is completed, R1 IP configuration is
Oh,
completed. Now we are waiting for ISP and ISP1 and ISP2. So let's come here, ISP1 and ISP2. So come to ISP1 device, conf t interface serial 2 by 0, IP address 12.1.1.2.252, no shut, and then interface loopback 1, IP address 1.1.1.1. Save. Now come to ISP2, conf t interface serial 2 by 1, IP address 13.1.1.2, no shut, and then interface loopback 1, IP address is 1.1.1.1. So IP configuration is completed in this scenario. Now is part of routing. See, if PC1 wants to communicate 1.1.1.1, which is internet address, see, destination host unreachable. Why PC1 is getting destination host unreachable? Because when the data is coming to, let me write some packet information, ping, ICMP. Okay. So when PC1 is sending ping request to R1. So R1 is saying that, okay, let me check whether I am reachable to 1 or not. So it will check the routing table. So you should come here, R1. R1 will check its routing table. So IP route, see, R1 is not reachable to that those ISP IP 1.1.1. That's why R1 is saying, my friend, see, UPC1 10.1 tried to communicate 111. R1 router said that, my friend, I am not able to reach that network, so it is destination host unreachable. So when it is not reachable, so what you have to perform? You have to perform default routing. Okay, so you when you will perform default routing, see how you are going to perform. Conf t router, sorry, IP route 0000 but I know my ISP address. So yes, what is your ISP address? It is 12.2. Yes, I have another ISP 13.2. So you'll configure like this. Now, if R1, your organization router will check the routing table, it will saying that yes, to reach internet address, I have two ISP, ISP1 and ISP2, ISP1 and ISP2. So now, if R1 means your organization router will try to communicate internet to reach internet here, okay, so you come here, first you see that whether you are able to communicate or not. See, so your organization router is able to communicate, but your organization router is using which path, ISP1 or ISP2? So if you'll try here, trace 1.1.1.1, it will tell you that, okay, it's doing load balancing, sometime from ISP1 and sometime from ISP2. Okay, now, but okay, do these PC will also able to communicate? No communication. Okay, now what communication you have to perform? Okay, so for basic lab understanding, okay, for basic lab understanding, here ISPs will say that, see, when the packet is going from your organization to ISP network, right? So when ISP will reply, so ISP reply path is not present in this lab. See, normally this is lab, it's not entire ISP design, right? Yes. So here when you will try to see why your system is not communicating. So if you will come to your ISP say that I'm ready to communicate, but I don't know where is 192.168.10.0. So if you will try here, so IP route, see, ISP doesn't know about 10.0 network. So for that you have two condition. What is the condition? Condition is either you, number 5, from ISP, means if from ISP to R1 network cre- create default route or static. First option is this one, from ISP1 and ISP2. Either you configure default or static from this side also. Okay, or we can perform number 6. Do you know NAT?
That?
Have you heard about network address translation?
Yeah, of course.
Yes.
We're using for
Yes, for internet access.
internet access.
Okay. So you have both option. So we will work on both. But NAT is a separate lesson. We will work on NAT. But for this
Mm-hmm.
lab example, when we are using ISP, that's why I want to show you both one. Okay.
Mm-hmm.
So if we are coming on ISP, so ISP I will say, okay, if there is no reachability, I can say IP route 0000 but I know where to reach. ISP2 will also do the same thing. ISP2 will say conf t 13.1.1.1, and when, if you now you check, so IP route. So for from your side also you have exit point, and now when the PC is trying to communicate, see, communication is there, no problem in the communication. And if you try to trace 1.1.1.1, see, is going via, okay, from this side trace 1.1.1.1, all is going via, okay, R1. So IP route, here it is doing load balancing. Okay, trace 1.1.1.1. So now see, reachability is there. Now everyone is communicating, and now you will say that, okay, how the load balancing is there. See, load balancing is there, but it's not showing you. But and here in this lab you have load balancing plus redundancy also. Redundancy means if this ISP right now, see, if you will see here, right now all users are communicating via ISP1, but
Mm-hmm.
if ISP1 will down, automatically they will start communicating from
Yes,
ISP2. See here, no problem. Let me come here to ping this one. I will say ping minus C one. Okay, they are communicating through ISP1. But if you will say here conf t interface serial 2/0 is shut down, means is down. Okay, interface is down. But you now see, interface is down, but still they are communicating. Okay, and
Mm-hmm.
now if you will break, control C, break the communication and check, they are communicating via ISP1 or ISP2.
SP2.
ISP2. Okay, so you have both option, redundancy plus load balancing. Okay,
Mm-hmm.
so this is the advanced type of lab. It means you can perform these type of things in the organizations. Okay, when you
Mm-hmm.
have two ISP. Okay, now you will say that,
Mm-hmm.
okay, sir, when we have two ISP, we configure our own device, but we cannot configure ISP. Okay, so in that
Yeah.
condition we configure NAT. Okay,
Mm-hmm.
yes. So when NAT lesson will come, then we will work on NAT. Okay.
Okay.
Now advanced default route. Advanced default route means we will work on floating default route. Floating default route, let me explain. Okay. Okay, see what is floating. Floating default route means by default your lab is doing load balancing. It is load balancing, right? But
Mm-hmm.
maybe your, like when we have two ISP, so from ISP 1, maybe this is Airtel and this is Vodafone or Geo, something like that, right? Okay, from this
Mm-hmm.
side, from Airtel I am using 100 Mbps link, and from this side I am using 50 Mbps link. Okay. Okay, so now, and in default routing do not understand about bandwidth. Okay, it will consider link, how many link. Okay, how many
Mm-hmm.
hops. Okay, so it will say, okay, from this way one, from this way one, so it will do load balancing. Okay, so your organization users, when they will try to reach, okay, so PC1 internet is fast, PC2 when it is load balancing, PC2 internet is slow. So it will say it will complain, and you as an administrator, you will say no, 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 maybe you will also think that this is wrong, right? Load balancing means everyone should receive exact speed. It's not that PC1 from the same LAN it will receive 100 and PC2 from the same network it will receive 50. It's not good, right?
Mm-hmm.
So you will say no, 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 this is not good. So you will say that, okay, no problem, the link with the speed 100 will be working as a primary link, right?
Mm-hmm.
And the link with 50 Mbps it will be working as a secondary. If primary will down, means if primary is working, first understand, if primary is working, all users from this network will go via primary. Okay, if primary will down, then everyone will go via
Mm-hmm.
secondary. So right now if you will check here, okay, so right now if you are checking on R1, see R1 it is doing load balancing. See, this is the load balancing. This uh, your router is going via ISP1 and ISP2 both. It's load balancing. But you'll say no, 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 I do not want load balancing. Okay, so you have to reconfigure the settings. Okay, and say that conf t, and what we can say. So first you have to delete the older configuration. So running configuration section IP route to check the older configuration. Then we can say, okay, conf t, whenever you want to remove any statements from routing, we say no and the same statement. No means to remove that statement, no, and this one. So I have removed the statement. Okay, and when I have removed the statement and you type here, so IP route, see no routing table, and when there no routing table is there, and when you are trying to communicate, see no communication, destination host unreachable. Okay, so I want to perform primary and secondary path. So I want to make ISP1 as a primary and ISP2 as a secondary, or ISP2 as a primary and ISP2 as a secondary. So you tell me what you want.
Mm-hmm.
So if you want to make primary and secondary, so what you do, So if you want to make ISP1 as a primary, so you say that okay, I want to make this administrative distance lower than, okay, lower. So you have to make this as a lower. So if you type nothing, means administrative distance is 1. Okay, so I'll say no, let me make this as a 10 identical, and for 13 2 I want to make as a 20. So 20 is higher. Okay, higher means not good, I'll say that okay, I want to go to some place. So from this way it is 10 kilometer, and from this way it is 20 kilometer. So 10 kilometer is
Mm-hmm.
lower, so 10 kilometer is preferable, so that is a primary path. Okay,
Mm-hmm.
and now it will store like that in the routing table. See, okay, link is still down. Okay, wait, sorry. Interface serial 2/0 no shut. Okay, now see, I have configured, and now you can see here serial 2 by 0 means the serial 2 by 0 is connected to ISP1, and this is the primary link. And now each every, it means if the PCs will try to communicate, everyone is communicating via ISP1. And if you want to trace and check 1.1.1.1, see, everyone is going via ISP1. Okay, now what I'm doing, I'll come here, ping, continuous ping. Now what I will do, I will say ISP1 is down. Interface serial 2
Mm-hmm.
by 0 and shut. ISP1 is down. And when ISP1 is down, and if you're checking your routing table, see, automatically path has been changed from ISP1 to ISP2. And now see your PC. Your PC has a downtime of just like a millisecond. And now see, your PC is communicating, and if you let me break this connection, and now check, see, it's, it's pinging, and if you trace also, it is going via ISP2. Okay, so you can say that okay,
Mm-hmm.
you want load balancing is supportable by routing protocols, but when you are receiving different type of bandwidth, then load balancing
Mm-hmm.
concept is not good, right?
Mm-hmm.
Primary and secondary is okay.
Yeah.
Okay, so same thing
Mm-hmm.
here is this, the lab is same here. So I have already explained you, and here you can see that it is saying that from this way it is 10 mbps, and from this way it is 5 mbps. So you want to make this as a primary, okay, and you want to make this as a secondary. So what configuration you will do? The configuration, see here, one means best, two means second best, right? Okay,
Mm-hmm.
and now this is your lab, student lab. So student will perform this design and this routing command I have given. Okay, but this is your lab. So now you have to perform this lab and check whether your router is going via this way or this way. Okay, so you can change this router 2 and router 4 as ISP1 and ISP2.
Mm-hmm.
Okay, now, okay, every time we check routing table, right?
Mm-hmm.
Okay, now tell me, what is, did you understood what is routing table and what is the use of routing table? Remember, in this lab also we say that okay, let's check routing table, right? We came to router 1, and we saw this is a routing table, right?
Yeah, yeah.
Yeah, so do you understand what is routing table? What is the use of
Okay.
routing table?
Yeah.
Okay, now see, routing table is one kind of map. Means
It's
you
showing
can,
us the
yes,
way.
you can reach to how many subnet, or you can say, simply say that okay, like our brain is one kind of routing table. We can say okay, I know how to reach Nehru Place, I know how to reach Beer Sarai, I know how to reach this place. So all path is there in your brain. right? So you can say this is the router brain, means any packet is coming, so router is checking his brain, okay, do I am reachable to that destination? Okay, so it will check this table. According to this table, router will forward the packet which is coming to router. Okay, okay, here you can see C means, what is the meaning of C means connected network. L means link,
Mm-hmm.
means this IP address has been configured on that link.
Mm.
Okay, and S means static, star means default.
Mm-hmm.
And what information you have in this table? See, you receive here destination network. Okay, the AD value of that network, that routing protocol, and this is the metric information. And if I want to reach that destination network, who will help me to reach that network? ISP 2. And if you see here, interface serial 2 by 0, no shut. Whenever ISP 1 will come up, and automatically routing is changed. Put up,
Mm-hmm.
see. Now your ISP1 is the preferable path now. Okay. So if anyone will ask what is routing table, so you can say that routing table is known as one kind of
Map.
map of the router, that okay, how I can reach, and means how I can forward the packet, right, from source to destination. And what information is there? You
I
can see here,
understood
when
already.
receive A wants to communicate, right, wants to communicate,
Mm.
so it will send the packet to router 1 will check in the routing table that okay, do I am reachable to 10.00 networks? It will say yes, you are reachable, and then it will forward. If it will check its routing table, and if the information is not there, it will drop the packet. So whenever router take forwarding decision, router before forwarding decision, router check its routing table. Okay, and we have already verified the routing table. Okay, now my question is, as we have completed our static routing, right?
Mm.
Okay, now my point is that if your, okay, now
There are noises. I cannot listen.
this guy is not saying. Okay, now see, if your router 1 wants to communicate to this internet address, right, and your router 1 is connected to ISP1 via default routing, and ISP2 via static routing. Okay, so it will
Mm.
prefer, your router, your organization router will prefer which path, default routing path or static routing path?
Sorry?
I'm saying, suppose you, this is your organization router. Okay,
It will be default, default.
default, no static.
Wait, come again. I didn't catch the question.
I'm
You can
saying,
speak. Yeah.
if your router, this is your organization router, your
Mm.
organization router is connected to ISP1 via default routing. Okay,
Mm.
and your organization router again, it is connected to second ISP via static routing. Okay,
Mm.
so when your organization router will forward the pack data, so it will prefer default routing ISP or a static routing ISP?
Mm. Static one.
Static one. Okay, now,
Yeah.
so can we prove this one? Can we check whether the statement what I am saying, it is correct or wrong?
let's check.
Okay, no, I'm saying let's prove and check. Okay,
Hmm.
okay, let's check and let's see whether the statement which I said is correct or wrong. So I will say that same thing. Okay, so here we are configuring default route. Okay, and from this way we are configuring static route. So let's come to your router one first. So running configuration section IP route, and we have to delete it first. Those are all statements what we have written. So I'll say no. Delete this previous configuration, because now we are talking about some scenario based. Okay. Yeah, Mr. Paul, do you want to understand this question?
Yes, I have to suggest.
Yeah, I'm saying, do you want to understand this question? I have asked some question from Mr. John that if,
Suggest. Yes.
yeah,
What is the question?
yeah, I'm coming. I'm saying that suppose you are the administrator of this organization. This is your organization router.
Hmm?
Okay.
I'm listening.
Now your organization router is connected to
Yes.
ISP1 with the help of default routing, and your organization is connected to another
Suggest.
ISP with the help of static routing. Now when your router is forwarding data, okay, so your router will prefer which path, default routing ISP or static routing ISP, because from both ISP you are reachable to Google.
Yeah.
Okay.
Uh,
Okay, so
yes, both are reachable. But the shortest, if my default is the shortest route for me to take, it is going to take the default.
yes, so I'm saying that can we prove this one and check whether it's correct or wrong, okay, or how it is communicating. Let's do it in lab, right?
Okay. Okay.
Okay, so now on R1,
Yes.
let's come to R1. We have to configure it, the lab according to. So
Yes.
from R1 to ISP1 is default routing. So we'll say that okay, IP route 0000 0000, okay, and the ISP address is this one.
Yes.
And from R1 to ISP2 is like 13.1.1.2, but this is a static, not default, right? So I'll say 1.1.1.1 255.255.255. Okay, so this one is the default statement towards ISP1, and this is the static statement towards ISP2. Okay, save it, and you will see that your PCs are
Okay.
communicating to 1.1.1. Your PCs are communicating to 1.1.1. But my question is, your router is forwarding your data from ISP1 or ISP2. So if you check here, so IP route, okay, it is forwarding via, you have both a statement, right? Default statement is also there and static statement is also there, right? But my question is, your data is forwarded via which protocol, static or
Yes.
default? So you check here, trace 1.1.1.1
By the default,
via default or static, check.
it's going before it the default.
No, no, my friend, it is a static. 13.2. 13 is ISP2 address. 13 is this one. Okay, even PC4 also, if you will trace 1.1.1.1, see, it is going via ISP2, not ISP1. Okay, now question will come how it is working. See, understand the difference between a static route and default route.
Yeah.
Once you will understand, there will be no problem. Okay, see, the routing table means whenever any packet is coming to your routing table, right? Okay, so your router will check
Yeah.
the destination address. Okay, so the destination address is what?
Yeah.
Yes, yeah, Mr. John, what
Yeah,
is the destination address?
yeah, I've seen.
The destination address is 1.1.1.1, right? Okay, so when the packet is coming to router 1, okay, so do that destination address is matching somewhere in the routing table? Yes, it is matching,
Mm.
and it is matching via static. It is not matching via default. Default will be used when destination address is not matching, then it will go via default. Default means first you try by your own, if not then you come through default. Understood? That's why static is always preferable. uh, if you have default, means it is always preferable than default routing.
Yeah, very clear.
Okay, okay, slowly you will understand the best path selection process. I was just saying this one. We have separate session also on best path selection process. Okay, but I was
Mm-hmm.
just saying that if you have default route means if any packet is not matching, then come to me and I will help you to communicate. But if any packet is matching, you follow your match. Okay, it's same like that. If you have something, okay, if you have any choice, please go through that choice. If no choice, then come to me. But if I have my choice there, so I will follow with my path, right? Okay, so we are done with the default routing. Okay, and next class we will be starting our uh, your dynamic routing. Okay,
Yes.
RAPE, EIGRP and OSPF. Okay, and with that we will be done with dynamic routing, and once the dynamic routing will be done,
Okay.
then we will move to our security part. Okay,
Yes.
but see, security part is that before security configuration you must know routing, because in security you have to manage your routing, right? You have to secure your routing communication, you have to secure your packets. So you must know your packet, how you to create communication between packets, right?
Mm-hmm.
Any question, Mr. John? We are done for today.
Sure.
Yeah, okay.